Hello everyone, welcome to our class. Today I will introduce to you to Lewis structure. What is you know about Lewis structure? Anyone know? Not really, alright? Okay. First of all, I will explain to you about the history of Lewis structure. Okay. Lewis structure was introduced by Gilbert and Lewis in 1916 by the article of Atom and Molecule. And what is the purpose of Lewis structure is to identify the electron valence in the outer shell of an atom, and it is show the bonding between two atoms and the lone pair content of the atom. And now I will explain to you about method of construction Lewis structure. Okay, first step is identify central atom. To identify the central atom, you must know where is the less electronegative atom and more electronegative atom. We will put the central atom which is less electronegative atom. And then the second one is count electron valence of each atom, which is there are two atoms and there are different electron valence. Okay. For the step 3 is place electron pair between two atoms, which is you can put single bond, double bond or triple bond. And the last one and the step 4 is put lone pair in the central atom. If we can have a leftover electron. Daniel, can you draw the Lewis structure of hydrogen cyanide in front and explain it to us?
Okay.
Come on.
Okay. Then on how to draw a Lewis structure for a basic compound, which is hydrogen cyanide. First step on to draw a Lewis structure for hydrogen cyanide, you must determine the central atom from the H, C or N. To determine the central atom, you must know which is the less electronegative between H, C and N. From this atom, it shows that C is the less electronegative than H and N. So C will be the center atom. So you draw like this. So C will become the center atom because of its less electronegative than N and H. The second step for drawing a Lewis structure for basic compound is to calculate the valence electron of the compound. So for this electron, it shows that we must calculate the valence electron. For H, for hydrogen, the valence electron is 1. For C, the valence electron is 4. And for nitrogen, the valence electron is 5. Add all of it is you get 10. So the valence electron is 10 for this compound. Now we will continue with step 3. Step 3 is we will draw the Lewis structure of it, which is a single bond. Like this, draw. See. Complete the octet for all of these elements. The octet is completed for this element. This is for step 3. For step 4, we will count the valence electron of the compound, which is, as you see, hydrogen cyanide it has 14 electrons. 14 electrons. So we will compare with the valence electron that we have counted earlier, which is 10. For step 4, we will count the valence electron of the compound, which is, as you see, hydrogen cyanide it has 14 electrons. 14 electrons. So we will compare with the valence electron that we have counted earlier, which is 10. For step 5, we will calculate the formal charge of the compound. This is to make sure that our Lewis structure is correct. To calculate the formal charge, we will draw like this at the structure. And for hydrogen, the valence electron is 1 and the electron in the structure is 1. So the formal charge is 0. For carbon, the valence electron is 4. The electron in the structure is also 4. So the formal charge is also 0. And nitrogen, the valence electron for nitrogen is 5. And the electron in the structure is also 5. So the formal charge is 0. So we will total up all the formal charge of the element. It will come total is 0. So the formal charge of your Joet Lewis structure is same. We can conclude that your Lewis structure is correct. So last, you will draw the complete structure, which is H, triple bond N, and there is a lone pair here. So the Lewis structure for ideal cyanide is like this.
Good explanation. Thank you, Daniel, for the explanation. And just now I heard about formal charge that you explained just now. Can anyone explain more about the formal charge?
Yes, sir.
Okay, go ahead.
Formal charge can be used to help in the assessment of resonance structure and molecule topology. The use of formal charge is present as a simplified method of describing structures. To calculate formal charge is number of valence electrons in a free atom of element minus number of unshared electron on the atom minus number of bonds to the atom. Charge on the molecule or ions are equal to the sum of all the formal charges.
And now there are three types of exception of Lewis structure, which is incomplete, odd, and also extended. Can anyone explain to me about the three exception? No? Okay, I will give you a task. In one paper, you have to elaborate the three exception and do it in the room and submit to me tomorrow. Okay? That's all for our class. You can dismiss now. Thank you.
A few inches later.
Let's do our tutorial this evening. Okay.
6.5 hours later.
Ira, do you know what is expanded octet? Expanded octet? Look there. Okay, expanded octet. So expanded octet is when there is more than 8 electrons occurs in the center atom. So it will never have a triple bond or double bond in the structure. For the example of the element or structure is for XeF4. So if you look at the periodic table here, Xe and F, Xe less electronegativity compared to F. So Xe put it in as a central atom. For the step 1, we have to count the total of electron valence for each compound. For Xe, it was 8 and F was 7. Then because this has 4 of fluoride, so we have multiply it by 4. Then we have total count all this 56 electron. For the step 2, put the least electronegative at the center like this. Then next for the step 3, put the electron surround the element. Okay. Right. So if you can see from the structure shows the 52 electron, but the real one is it has 36 electron. So we have the 4 electron as a lone pair here, like that. So it shows that the central atom have more than 8 electron and equal as a expanded octet. Nuri, yeah, can you 17 upon the odds of 10? Sure, it's easy. Look at that. Where? There. Of the odd octet compound, which is nitrogen dioxide. Step 1. You must put the compound that less electronegativity in the center of atom, which all the number of value is 5, 4, 6, but O have 2, so we have to multiply with 2, 17 electrons. Surround the element and count the total of electron. As you can see, the total electron is 20. So we have to remove the electron to make it same as we calculate before. Remove 2 lone pair and put 1 bond here, so we get 18 electron. Show 18 electron, but the compound that we calculate before only have 17 electrons. So we have to remove 1 electron at this atom. So we get 17. Next step is we must calculate the formal charge to confirm the compound is correct or not. Okay. First, the valence electron for N is 5, but at this compound it also have 4, which is 1, 2, 3, 4. We have a minus, and we get positive 1. For oxygen, it have 1, 2, 3, 4, 5, 6, 7, 7. 6 minus 7, we get minus 1, and this 0. So if we calculate all the formal charge, which is 1, we get 0. So the formal charge for this compound is 0, same with this compound.